Assalamualaikum and hi everyone. Today we will present about the hydrology project which is conducted at Station Lada Payalang, Station Kampung Bangas and Station Sekolah Kebangsaan Sepangloi. So this is our team which is Muhammad Amirul Aiman bin Amir, Izabu bin Khairul Anwar, Muhammad Hafiz bin Faizul Azmi and Nur Alisa Azati binti Muhammad Asri. So we will proceed to the introduction. The weather in Malaysia is tropical with high humidity and mild temperatures all year long. When it rains, the water is absorbed into the soil by plants, where it evaporates and then returns to the atmosphere. When the amount of rainfall exceeds the sun's ability to absorb it, outflow occurs. According to the theory, if the intensity of the rain is high, the water level should rise, and as it does, the stream flow will be impacted. Depending on the intended usage, different time periods will be used to collect data on water level. Short-term water level measurements are taken over days, weeks, or months during different sort of groundwater investigation. Within a month, our team will get the data it needs for this project. From the following station, we gather our data at Station Lada Payalang, Station Kampung Bangas and Station Sekolah Kebangsaan Sepangloi. So next is problem statement. Recent years appears to have an increased the threat of flooding. Two of the main causes of flooding in Malaysia are expansion, extending into an accompanying flood plains and irrigation corridors, which result in a loss of flood storage and increased runoff rates owing to urbanization. Using rainfall and water level data from the station Sungai Muar in the Buluh Kasab district of Johor, this project aims to determine the average annual precipitation of the suggested catchment area, the peak flow of the proposed catchment location, the discharge of the river at the highest possible level, and the unit of hydrograph. Hydrographs are part of them, like peak rates, are utilized in the planning and construction of water control system. They are also employed to illustrate the hydrologic effects of ongoing and potential basic activities as well as land use modification. So the objective for this project is to calculate the chosen catchment area's mean annual rainfall, to examine the selected catchment location peak flow and river discharge at its highest water level, and to determine and plot the unit hydrograph for the proposed catchment area. So for the methodology, first we need to find rainfall and water level data on the official website of Info Banjir. Next, by using Google Earth Pro, our group finds several data such as the location of proposed rainfall and water level station, terrain profiles, and gradient slope for proposed catchment area, and also cross-section of the river. Finally, we perform calculation tasks such as finding peak flow to create a hydrograph for each cross-section of the river based on the data we obtain.
So as we can see here, we have two pictures of Google Earth Pro. So the function of using the Google Earth Pro is to find the slope for the calculation. As we can see, the picture of number one is the path one from station Sekolah Kebangsaan Sepangloi to station Kampung Bangas. And for the second picture is for path 3, station Ladang Payalang to station Sekolah Kebangsaan Sepangloi. So from the graph here, we can see or we can get the data needed for our calculation.
Okay, next, we need to make a cross section at three places in the river that we have chosen, which is top, middle, and lower of the river. Using the Google Earth to get the data that need to be used in the Manning equation.
So we move to the rainfall data. There are three methods to calculate the mean area rainfall. Number one is arithmetic mean method. The second one is descent polygon method, and the third one is isohetal method. So we need to find the mean area rainfall for all the study area, which means we need to calculate all the area involved before we calculate the method. So for the calculation for arithmetic mean method, there is formula which is sum of xi divided by n, and we get 194.33 millimeter. For the Thiessen polygon and isohedral method, we use the same formula which is precipitation average equal to area I divided by area times precipitation. So the value for this polygon method is 195.90 millimeter, and for isohedral method is 208.9 millimeter. So after we done with the calculation, we need to plot the value into the graph. So this is called as hydrograph, and we have three hydrograph because of three cross section area, and the graph was involved by Q versus time.
Okay, I will explain about the peak flow calculation. There are two methods for this part. First is rational and second is meaning. For rational method, there are some steps that we use, such as find the slope for the land river, find the water roughness, find the runoff coefficient, find the value of slope over land surface, find the overland flow time, find the average rainfall, and lastly, we calculate the peak flow. Okay, for many methods, there are just three steps we use. First, calculate the perimeter for every cross section of the river. Second, determine the meaning roughness coefficient, and lastly, we calculate the peak flow for each cross section of the river. Okay, so our proposed catchment area is made up from a flat land surface and also covered by an average height of bush. So from there, our Houghton roughness value is 0.045, our runoff coefficient is 0.4, and our overland slope surface is 0.8%. Okay, next, our overland flow time value is 78 minutes. From that overland flow time, we can find our rainfall intensity by using the MMSA second edition graph. From that, our rainfall intensity is 28 mm per hour. Finally, we can calculate our peak flow by multiplying our runoff coefficient, our rainfall intensity, and our area, and we get 1181.04 meter cube per second. Okay, next, for the Manning equation method, first step we must identify the shape of our cross section river. Basically, the shape is all in trapezium shape. Next, we must write down the width and depth for all the cross section river. After that, we can calculate our discharge value by inserting the slope value, the Manning roughness value, the perimeter value, the cross section area value, and also the hydraulic mean radius value. And finally, we calculate the total peak flow and average peak flow for all the cross section of the river. Okay, this is the value for all the data required for second and third cross section area.
Okay, next, for the discussion we can make from this study. In engineering application, it is crucial to obtain representative rainfall data for a given region, as opposed to spot rainfall observation. Therefore, we will employ three different approaches to calculate the area rainfall using the data recorded by multiple rain gauges within the region. We will calculate the data using three types of method, which is arithmetic mean methods, Thiessen polygon methods, and isohedral method. In conclusion, the objective of this report is to examine the cost of floods in Malaysia, determine the location of the rainfall station, and explore the usage of Google Earth Pro. This software facilitates the collection of aerial image of the terrain and the gathering and analysis of geographic data for various purposes such as analysis, planning, and decision making. With Google Earth Pro, one can identify and delineate properties, measure land and area for commercial development, and define parcel and boundaries line. That's all for the conclusion for this report. Thank you.